Okay, so in this problem, we move on to the next topic, which is multiplication using binomials. So usually what we're going to have here is that we're going to have a binomial. So we will take a binomial, which is basically a polynomial with just two terms with it. So remember, terms are defined as being anything separated by an addition or subtraction sign. So in here, I have two things that are being separated. And then if I look at the next one, I have two things as well. So what this problem is called a binomial times a binomial. Now, there are many names that teachers will give this, which for the method to do it, so the method that they will say to do it, one of the common ones is called this term is called FOIL. And FOIL is just an acronym for, it stands for first, outer, inner, lasts. And basically, I personally don't use FOIL. You are more than welcome to use FOIL. What I just use is I use the double distributive property. So double distribution, and that's all I use. Okay, so it ends up being the same thing as FOIL, and I'll explain that in a second. But let's just go ahead and do this example. So when you have polynomials multiplied by another polynomial, what you simply do here is you're going to take each term that's in there and you're just going to distribute it across to the next one, across to the next group. So that means I'll take x and I will multiply it by x. All right, so notice what I do here is this is where the acronym FOIL comes from. I take the first two terms and I multiply them. So the first two terms from each polynomial will get multiplied, all right, and that gives x times x, which is x squared, all right. But then what I'm going to do is I have to do double distribution. So I don't just look for x's and x's, I do have to double distribute here. So I must distribute that x again also over to the second term. So that means x times -4 is -4x. Now you can't forget that, okay? It's important. It's an important process that we do here. So this is basically now where the O comes from. The O comes from, they use the acronym outers. So if you were to take a look at this polynomial, all right, and you were to take a look at who's on the outside rim, like these are on the inside, these two would be on the outside. If you're thinking about seats, these two are on the outside, these two are on the inside seats. So that's where it comes from. This O stands for outer. So you're going to multiply the firsts, then you multiply the outers. And then this I, guess what? It stands for what I just used before. It multiplied the two that's in between. Now, I just call this double distribution. So I've distributed the x across. And now the double distribution means is that however many terms are in here, I must just distribute it to the second group. So after I'm done doing my distributive property with the first one, okay, I can then go ahead to the second one and do my distributive property. Now, normally what we do here as a technique is we'll write the first distribution up top, and the second one we'll take our arrows and we place them on the bottom to show that. So if you see your teacher doing that, it's just a common technique that people use, so you don't have all these crisscrossing arrows all over the place. You just have only two of them crossing. So here goes the inners. So the inners is the 2 times the x, which is plus 2x. And then you have the 2 times the -4, which is -8. So again, this thing has many names. You can call it FOIL, you can call it double distribution. It's really whatever you want. You just need to learn the process that we're going to be distributing each term in the first group to each term in the second group. All right. So notice, all right, I have 4 multiplications here. So the last step here, though, is unfortunately I'm not done, because essentially what this most times does for you out of Algebra 1, if you're watching this is basically an Algebra 1 video, what you will see here is that we create what is called a like term, which means this middle term here, this -4x, and this other term here, this positive 2x, they're like terms, which means I can go ahead and I can combine them. So in this case, okay, the x squared will drop. So I get x squared. And now just remember that when you're doing this, all right, everybody gets in the habit of when you're multiplying these things in a problem that they start always like combining exponents, but just make sure a like term, okay, you don't get to change the exponent. The variable now will stay locked in, okay? So it stays as an x. Do not make it like an x squared, all right? And then this is -8. And there you go, you have it. There's my final answer. All right. So that is how you do those problems. So I have 5 examples of binomials all over the place. So I'm going to go a little bit quicker through the next ones, just so that You understand it? Now, also, you're going to want to leap forward, or, if you don't want to watch the other examples, you're like, oh, I got this. You might want to just leap a little bit forward towards the end where I do a binomial times a trinomial. Yeah. So if you want to fast forward to that, go ahead to save yourself time. But yeah, it's going to be pretty much the same thing. So let's go on to the next example. All right, so next example here, I'm just going to go through and do this. So what I have here is I do the distribute the first term. So distribute the first term. So distribute to both the 5x and the negative 4. So 3 and 5 makes 15. X and x makes x squared. 3 and negative 4 make a negative 12x. I then go ahead and I distribute the second term. Okay, 2 across, so negative 2 times 5 is negative 10x, and I distribute the negative 2 to a negative 4, which makes a positive 8x. And what you will begin to notice is that sometimes here we get these things called like terms that get created, and there you go. There's my two like terms highlighted in green. So my final answer is going to be this 15x squared, and negative 12 and negative 10 makes negative 22x, and then I get left with this plus 8, and then there's my final answer. Okay, on to another example here, just demonstrating the same thing here. So on to the next example. So the next example is a little bit tougher because it involves multiple variables this time. So because it involves multiple variables, sometimes people get confused by this, but you follow the same rule. So I'm going to double distribute this 2x, so distributing the 2x. So the 2x times 4x makes 8x squared, and the 2x times the negative y makes a negative 2xy. And then what I will do here for my second one here, right, it's the double distribution. It's the 5y multiplies then both of those two. So notice I'm just plucking the second term, and I go through. So 5y times 4x is going to be 5 and 4 make positive 20. X and y just make xy. And then the last one I have is 5 times negative 1, which is negative 5, and y make a y squared. So last but not least here, what I have to do is I have to look for like terms. And like terms are going to have same variables, same exponents. So what you will see here is that if you take a look at this, what I've got going on right here, right in the middle, is this negative 2xy and 20xy. So those are like terms. So what I can do is I can combine them to finish up this answer. So I get 8x squared plus 18xy, and then there's this minus 5y squared attached to the end, and then I'm done. All right, so there's the final answer for that one. Okay, on to the next example. Okay, so in this example here, this is where I introduce this idea of a binomial times a trinomial, and don't worry about it. It's just more, to be honest with you, it's just more multiplications. It's not necessarily any harder, it's just more. So I take this first term, all right? So I start on the left term, and it doesn't matter for multiplication. You can start left or right, but I personally always start on the left. So I take this x, and all I'm going to do is distribute. So I have 3 distributions I have to do this time with that x, not just 2, because there's 3 terms in the second group. So I do x times x squared, which is the first, which makes x cubed, and x times positive 3x, which is 3x squared. And then I do x times the negative 2, just following my arrows, and I get negative 2x. And then what I do is I move over to this positive 1, and I then distribute that. Okay, so I'm just doing a bunch of multiplications. So 1 times x squared is positive 1x squared. And 1 times 3x is just positive 3x, and 1 times negative 2 is negative 2. Now, well, again, what makes these problems not completely done yet is now I have to go ahead and I have to start looking for, do I have like terms? So in this problem, what I will do is I will scan through here, and I'll start noticing variables with the same exponents. So I have an x squared and an x squared, and then I also have an x and an x, all right? So those are the same thing. So what I get to do is I get to combine their coefficients. So if I want to write this in standard form at the same time, what I will do is I will scan across, and I will look for the highest exponent, which is x cubed. And then I will then look at my like terms, and before I start just combining them, I will say, okay, who's the next highest? What's the x squared? So this becomes the positive 3 and the positive 1 makes 4x squared. And then the last step here is to look at the next one. So I get the negative 2 and a positive 3. So what I'm looking at right here, just so you see it, is this negative 2 can combine with this positive 3 because their variables are the same. And negative 2 and positive 3 makes a positive 1x. And then I'm left with, at the end, this negative 2, which has nothing to combine with it. So my final answer now in standard form is there you go. Now, if you just want to look for your like terms, add them all together, and then switch it to standard form, you can do that as well, all right? But on to my last example for this video, which is going to be another binomial times a trinomial. All right, so here we go. The only thing that makes this a little bit more challenging is I've just put more coefficients with the problem than I had before. So here we go. Going through this problem, if I take this 2x, I'm going to distribute. So I distribute it not just once, not just twice, but now 3 times because the second group dictates how many times I have to distribute. So 2x times 4x squared, the 2 times 4 makes 8. Okay, so remember when multiplying, the coefficients follow the rule. But when multiplying variables, their exponents are added. So this is 8x cubed. So just going to the second distribution. So 2 times negative 3 is negative 6. And x make that an x squared. And then the 2 times negative 2 is just going to be a negative 4. And then I place an x with it. So it's negative 4x. And then I just simply go ahead to my next one. So now that those are all done, I go on to my next one, which is a negative 1. And I'm going to go ahead and I'm going to distribute this negative 1 to each 3 of these terms. So a binomial times a trinomial is not necessarily a harder task, it's just more task, okay? It's more of a busy work type of problem. So here we go. Negative 1 times 4x squared is negative 4x squared, and negative 1 times negative 3 is positive 3x. And then negative 1 times negative 2 is positive 2. And then we're not done here, because generally what we have to do here from a lot of the time is we have to look for, do we have like terms? And again, what I've got here is an x squared with an x squared. And then I've also got highlighted in yellow is a negative 4x and a positive 3x. So again, I'm going to have to go ahead and write these out. Now, the things that aren't highlighted, they don't have any like terms, so they're just going to come along and be in the answer. So notice my leading coefficient, my leading term here already is the highest power. So if I'm putting this in standard form, I get 8x cubed. I will then move down to the next step, which is a 2. So I take negative 6 and negative 4, and I'm going to make that a negative 10x. Just remember, you do not get to change the exponent, so it's x squared. And moving on to my terms in yellow, so negative 4 and positive 3 makes a negative 1x. You don't have to write that negative 1. It's very common that people won't. And then I move on to my last one, okay, which is just that positive 2. And now what I've done is I've highlighted these things and I've checked them out and I've just done them so that they're now in standard form, which is just writing the exponents in order from least to greatest. So I hope that helps. I know this one was a little bit longer, but there you go. That is how you multiply using binomials.